Hey everybody, welcome to another one of our much anticipated demo arena sessions here at NestGen 2022. Within the next hour, I guarantee you're about to be blown away because you'll be the first to view the launch of the modular docking station CounterDome, engineered by CounterDrone. If you aren't yet overwhelmed, let me quickly change that for you. You're about to witness the world's first multi-drone docking station. To understand better, CounterDome is a hemispheric enclosure for autonomous drones. It can uniquely accommodate most commercial drones, including two Mavic-sized drones for twice the mission's redundancy and threat response. To enlighten us on this game-changing product, I would like to invite Mr. Sean Jafarian. Sean is the founder and CTO of CounterDrone. CounterDrone, as an enterprise, has helped create multiple CUAS, also known as Counter Unmanned Aerial System programs for the US military. For the past 6 years, Sean has provided engineering services to multiple US government agencies under Counter Unmanned Aerial System contracts. He has designed and built custom drones for 9 years. His drone expertise extends beyond design to include complex real world operations and regulations. Sean is a former US Air Force pilot and FAA certified commercial pilot. While I can gladly and would go on about Sean and his many other accomplishments, I understand the audience here is really looking forward to his presence. With that, over to you, Sean.
Thanks, Havish. I appreciate that introduction. I'm going to share our presentation. So hello, everybody. I'm Sean from CounterDrone. Thank you for joining us for this introduction to our new drone docking station, the CounterDome. We've been developing this system for a little over a year now, and it is part of our effort to field autonomous drones in the security and safety and life safety missions. That said, the docking station is suited to a wide variety of autonomous drone operations, from surveying to surveillance to inspection missions and more. We believe a docking station needs to be highly reliable in a wide variety of climates, weather resistant, and adaptable to an assortment of different drones. The software that operates the station should also be composable and should readily integrate into other existing infrastructures, such as security, video management systems. The station should also not be married to one particular craft. For instance, an LTE-equipped drone should be able to launch from one station and land in a different station several miles away. So we decided to develop a single modular docking station that can be used around the world for a host of different missions and with many different drones. We selected a clamshell dome for our docking station for several reasons. First, it is wind resistant from all directions. For several autonomous drone applications, a rooftop mounted station is desirable. Therefore, being able to withstand high winds without moving or tipping over is very important. The clamshell dome will also not accumulate moisture or debris on top. Each leaf nests within the adjacent leaf, and weather stripping helps create a tight seal. So the system is highly resistant to precipitation and dust particles. The clamshell dome also allows the system to actuate wherever it fits. It has essentially the same footprint when it is open, closed, or actuating. So it fits in the back of a truck as easily as on a rooftop. The dome can open or close in about a second and a half, allowing for rapid launches and minimizing the time the inside is exposed to the elements. The circular floor is area efficient, important for our drone agnostic and multi-drone approaches. For security and some safety of life missions, drones should be powered on and have a GPS fix at all times. For this reason, and also for the sake of command and control links, we needed the station to be radio frequency transparent. Fiberglass provides this capability while also being strong and highly weather resistant. This allows us to have all antennas internally mounted, enhancing the station's weatherproofing. And it also just looks cool. and is right at home on a modern rooftop, mounted on a tower, or in the back of a truck. We set out to develop a system that could accommodate different types and sizes of drones. And as we did that, we quickly realized that there are lots of new emerging autonomous drone missions that would benefit from having 2 drones in a single docking station. This has obvious benefits in the security mission, as 2 drones can provide better situational awareness while also making their presence known to potential intruders. Imagine a scenario where one drone equipped with a loudspeaker is at a lower altitude confronting a trespasser, while the second drone is orbiting the scene at a higher altitude, providing illumination of the scene from an onboard floodlight. Furthermore, redundancy is important for any mission-critical task, and having the ability to operate a backup drone in the event the primary drone malfunctions seems very useful. During our integration development with the widely used security integration software Milestone X-Protect, we tested a drone methodology whereby one craft would fly a pre-planned autonomous patrol while the other would stand by on alert, waiting for a triggering event such as motion detection from a security camera or some other ad hoc trigger, door alarm, fence intrusion, etc. 2 drones can essentially act as partners. Dual craft in a single docking station also facilitates more time in the air by allowing one to recharge while the other assumes the previous mission. With certain custom drones, the CounterDome station can provide a charge rate of greater than 2C, which means 2 drones can provide a near persistent airborne presence. For example, if each drone has a 30-minute flight time and the batteries can safely charge at over 2C, the battery takes less than 30 minutes to replenish, allowing for the drones to relieve one another and resume the mission. There are also missions that can benefit from 2 completely different types of drones. Pictured on the right is a Pixhawk-based drone running Arducopter in the aft position of the station, and a Mavic 2 Enterprise equipped with a loudspeaker in the forward position. So as another example, for some agricultural missions, a site could benefit from a drone with a multispectral sensor for crop yield analysis and another with a general purpose camera for surveillance. And because the CounterDome uses 2 independent charging systems, we can charge the drones at different voltages and currents, all in the same station. The 2 drone configuration is for drones of approximately a 350 millimeter wheelbase, so about Mavic sized, or the size of the custom Arducraft seen in the picture. In the following 2 videos, we see the 2 drone concept at work from 2 perspectives. So a little history about how we developed this docking station. This has been in the works for about 16 months now. The first prototype was completed in July of last year and tested at the University of New Mexico. It was about 10% larger than the production version and used a chain drive system. The prototype opened or closed in about 4 seconds. It did not include a climate control system. In September of last year, the university campus police agreed to deploy the prototype system in support of campus security operations. The lessons learned from the prototype included better weatherizing through improved sealing of the dome and internalizing all of the drivetrain components into the dome's subfloor. Fiberglass manufacturing processes improved, and the entire drivetrain has been redesigned for the production version. For the production system, we developed a brushed motor linear actuator drive system that uses 4 motors and redundant power supplies. 2 motors drive one side of the clamshell leaves. The linear actuator system is considerably faster than the prototype's chain drive, opening or closing in less than 1.5 seconds. Linear actuators also tend to be extremely reliable. They're often found in critical aerospace applications such as aircraft landing gear and control surface actuation. By shrinking the base of the prototype dome and reducing the space between leaves, we were able to reduce the overall size by about 10% while increasing the total area of the landing floor. Landing floor is 10.5 square feet, or about 1 square meter. The production version uses an electric heater as standard equipment with optional refrigerated heat pump for air conditioning in hot climate deployments. Our testing with the original prototype also led us to offer multiple router options, including dual band and dual SIM units. So the CounterDome docking station features contact charging. A charging kit is adapted to the drone that allows for the corrosion-resistant charging pads in the floor to provide current to the drone's battery. In the case of the DJI drones, this kit connects to the drone's battery and both of the rear legs. DJI drones can also be equipped with a modified battery we provide that allows for remote reboots of the drone. In the 2-drone configuration, the station uses independent power supplies that can simultaneously charge 2 drones at different voltages. Up to 8S batteries are supported. The charging rate is user configurable. Most DJI batteries tend to prefer about 1C charging rates. However, higher rates can be set for custom drones batteries as appropriate. Battery status, including voltage, instantaneous current, and total current over time, can be reported via software. Another unique feature of the CounterDome is modular charging floors. The floor can be easily swapped out for a replacement of a different configuration. A single drone floor is available that can accommodate drones with a 550 millimeter wheelbase or smaller. Charging pads and fiducial landing tags can be easily arranged based on your specific applications. For 650 millimeter framed drones, such as the Matrice series, we are going to be accommodating this later this year via a frame and prop centering floor. This is currently under development and consists of robotically actuated levers that ensure the drone is clear of the dome's leaves during actuation. The dome can be powered by 120 volt or 240 volt alternating current. The drivetrain uses redundant power supplies, as does the charging system. Onboard temperature and humidity sensors report the internal climate, and an electric heater is standard equipment. A heat pump-based refrigerated air conditioning module is optional equipment. With that unit, we can keep the inside below 80 degrees Fahrenheit when the outside air temp is as high as 120 degrees. The system's equipped with an LTE router for internet connectivity. An Ethernet connection is available for sites where cellular is unusable or undesirable. The router is housed below the modular charging floor, allowing for easy SIM card swaps. This customer accessible area can also be used to store additional hardware such as batteries, drone accessories, or even folded up drones. This can be advantageous as battery health can be extended by rotating them as appropriate for the site's operational tempo. Safety and reliability have been our top priority in the development of the CounterDome. Several methods are employed to ensure that the clamshell leaves do not close when a drone could be damaged or when another obstacle is present. In the case of the Mavic 2, in the 2 Mavic 2 configurations seen throughout this presentation, The charging pads are sized and spaced in a manner that provides clearance between drones and clearance from the clamshell leaves when the drone is in the proper charging position. If a drone does not land in a position that allows charging to begin, the dome will not close, and the drone will be instructed to reposition via a short climb followed by another precision landing command. Due to the speed at which the clamshell actuates, it's important for the leaves to stop if an obstacle is detected. The system will also send an alert to the user that a clamshell obstacle has been detected. Upon landing, the system tests for polarity and continuity. The charging system has multiple safeguards built in to prevent damage to drone batteries and the docking station hardware. This includes short circuit protection, overvolt, and overcurrent safeguards. And all 4 docking station power supplies are fuse protected. Being that the dome is equipped with its own internet connection, it can report to the user when potential issues are starting to manifest. For instance, if the current being used by one of the linear actuators is higher than expected over multiple actuations, an alert is sent calling for inspection of the actuator in question. Later this year, we'll be offering additional capabilities and upgrades for the CounterDome station. We continue to test and integrate new drones, and next on the list are the Mavic 3 series, the Autel Evo line, and Parrot drones. As mentioned earlier, we are developing a modular floor with a robotic centering system for 650 millimeter framed craft, such as the DJI Matrice series. Expect to see this in the summer of this year. We also build custom drones at our facility using the open source RGU and PX4 flight stacks, including LTE connected drones, which will soon become commonplace in a broad range of applications. DJI has now entered the LTE arena with a dongle kit for the Mavic 3 line. The flexibility that LTE drones provide means we can launch from one CounterDome station and land in another. For instance, a scenario where drones are patrolling a large area that includes one-way travel from one station to the next, or a pursuit scenario where one drone is tracking a subject into an area where a second station is located. Then, when the second drone launches to join the pursuit, the first drone replaces it in the docking station to recharge. The point being, there's no reason that drones must recover to the same dock they launched from, and this is something we intend to implement via software this year. We envision a future where a network of connected drone docking stations can provide multiple users access to a wide range of robotic airborne capabilities. In time, drones will become subject to the same network effects that other tech advances have been defined by. And part of the infrastructure that will support this is an expansive array of drone docking stations that can accommodate a variety of different types of craft. This summer, we will also offer a battery backup option as well as foldable solar panels for off-the-grid applications. So stay tuned to our website for these updates. Late last year, we began testing Starlink internet with a FlightNow cloud-based application. As the Starlink constellation matures, its speed and latency is proving to be more than adequate for autonomous drone operations and the associated video streaming. So the combinations of solar panels and Starlink will provide a true off-the-grid capability for deployments in very remote locations. And lastly, we will also be integrating an external weather station by the end of spring of this year. So these are the dimensions of the CounterDome station. You can see behind me one that's open, one that's closed. The height values can increase by a few inches if optional feet are installed, and this is something that is really depends on the location that the customer intends to deploy the unit. Currently, all CounterDome units are made to order. For instance, certain customers may not ever need to deploy DJI products, in which case several hardware components are omitted. Other options include the air conditioning system and the use of a single drone floor. So at this time, we do encourage people that are interested to reach out to us so we can talk about your specific applications and get you accurate pricing for the unit that is best tailored to your needs. So that concludes our introduction to the CounterDome.
Yes, thank you, Sean. As a viewer and a drone enthusiast myself, I have found this thing to be very interesting. Like, I don't think in the current lineup we actually had any docking stations with two drones supported at this stage. And right now, this is probably one of the most futuristic and fascinating products that we have. So let us start with the polls. During the presentation, I had put up two polls, and I have the results for it. So the first was if the audience. So the first was the drone docking station, right? And five people have voted that they see, but only with two drones, while varying amounts of other people have voted that some of them don't see any value in any more than one drone. One person has voted that they see value in three drones, and two people have voted that they see value in more than three drones.
Mm-hmm.
So, what are your comments on that? Like, how did you decide that while building a multi-drone docking station, two was the right number to go for?
Well, it seemed like the best starting place, particularly for craft that are of the Mavic size or thereabouts, because it kind of gives a hybrid approach to the contact charging versus the battery swapping, because it could be argued that it's actually a faster response as far as getting this second drone in the air than the battery swapping can offer. But at the same time, it has the same benefits of the contact charging. So that's why we started with two. But the fact is, the industry is so new, right? This space is just getting started.
Yeah.
And I guess we're trying to foresee new missions before they're being implemented in the field. And we do think that particularly in certain security missions, the two drone approach will prove to be very advantageous. Given that part of our thought process here for security was that this could help to remove human security guards from certain dangerous situations.
Right.
And having two drones responding to a situation could be a greater deterrent than a single one.
Right.
And so that was part of that calculus. However, as we mentioned, the station is large enough that if someone so desires, we offer the single drone floor instead.
Right. And also, I believe the idea that you put up that if for response to any incident, you would send two drones while one of them is hovering lower and maybe talking to the person, and the other one is flying higher with a point of view. This again is something that is really unique that has, I think, happened throughout NestGen, and that's really great to know. So
and as drone capabilities increase, particularly using machine learning techniques, those two drones will be able to assist one another.
So what do you mean when you say that they would be able to assist one another?
So, well, like you mentioned, the scenario whereby one is engaging at a low altitude, and the other is engaging in a manner that puts the entire engagement in its field of view.
So that the bigger one is kind of giving a good perspective of the things that are happening down below.
Yeah.
So the drone which you mentioned, which is going to be engaging at a lower altitude, is it going to be one of the DJI Enterprise series, which has a speaker on board, or which has lights on board, something like that?
Yeah. So that's one example. Is a dual enterprise configuration where one drone has a speaker, the other has the flood lamp.
Right.
but similar tactics could be employed with custom built craft as well.
Uh-huh. So do you mean one can have some sort of a net which can be used to catch one of the drones, and the other drone kind of records the whole process and something like that?
Yeah, yeah. I mean, there's no reason you couldn't use this system in a counter UAS style mission if you had drones equipped for that as well.
Right. Right. Okay. So one of the other poll questions that we had was that do we want a docking station which can support more than one type of drone? And the audience has unanimously decided that yes, they definitely do want a docking station which can support more than one type of drone. Can you so the question would be like every single different type of drone has a different battery capability, right? So they would require their own different battery chargers and things like that. So how would you accommodate this variation in your docking station, which could be drone agnostic going forward?
Yeah, so there's several ways that we can do that. The first is through the placement and spacing of the charging pads,
Right.
which obviously we can also move the fiducial landing tags as needed.
Right.
We can also assist with the development of custom-based drones that have the ability to charge natively on board without any kind of kit. So we've built a Pixhawk-based craft here in-house that is meant to charge off of this station, from the beginning.
Oh, right.
So, and that's going to be important going forward. So DJI makes incredible drones. There's no question about it. But we also have to take into account that there are other drone manufacturers out there that are up and coming, and there's also a political climate in certain countries that are not so welcome to DJI drones.
Right.
So we don't know exactly what this landscape's going to look like in a couple of years from now. It's not likely that DJI is going away, but their dominance could start to decline through the rise of other drone manufacturers around the world and this political action to sort of stifle DJI. So we've had to take that into account. And working with the DJI SDK, as Flight Now well knows, it isn't necessarily the most friendly.
Yes.
DJIs are not really built from the ground up for true autonomy. And,
right.
And that's been stated by the company itself, right? There was an article on Medium last year, or Skydio kind of called out DJI for this, that, DJI's mindset is that they want an operator present all the time.
Okay.
So we've had to kind of tweak things in order to get these DJI craft to be autonomous in the way that we want them to for certain missions. Now, if we're building our own craft using PX4 stack, Argicopter, open source hardware, this isn't nearly as much of an issue.
Right.
So that's really one of the biggest reasons why we focus on a drone agnostic approach.
Right.
Because the drone industry is just in its infancy right now. We didn't want to get married to one particular product.
Right. So it's a smart decision on the business side too, right? You're not putting all your eggs in the same basket. If DJI fails, it still means that you're okay.
And as we all know, DJI is also working on their own docking stations, right?
Right.
And chances are excellent that when DJI releases their docking station, it's going to work better than any aftermarket station that is dedicated to a DJI product.
Right.
So again, that's another reason that we aren't really married to them. We like
right.
DJI drones.
Yeah.
If a customer wants to use them, by all means.
Yes.
If a customer doesn't want to use them, then we can work with that too. So that's really our philosophy regarding the drone agnosticism.
That's great. So we have a bunch of questions from the audience. Like the first one is, what is the price range? I mean, you did mention that it would be custom fitted and they would have to get in contact with you, but can you just give an overall price range for how much would one of these devices cost with a double drone configuration, which is, I guess, the most popular one?
Yeah. So we are going to be doing a separate launch event in late March, early April, where this will get spelled out specifically. However, right now we're comfortable stating that options dependent. So the most basic option station will be 30,000 US dollars,
Okay.
and that will go up to 35,000 US dollars for more advanced options and accessories.
All right. Okay. That's great. So the next question is like, what manufacturing capacity do you expect to achieve this year? And how many systems do you believe you can deliver by the end of the year? If let us say you had enough sufficient orders, of course.
So presently, we're anticipating being able to produce one complete system per week by the summer of this year, and we do have multiple systems being built now. So our goal is to have 40 to 50 systems by the end of this year.
That's great. And one of our audience has a really unique question. So they're asking if you are still in beta testing, and he would actually like to provide you a test bed for testing if interested.
That's something we would be open to. Is that question listed here in Q&A?
I can approve it. Just give me one moment. Yes, I think it should be visible to you now. So the it's actually under an anonymous ID, so I don't think it should you would be able to get in touch with
Okay,
it.
can you just read it one more time?
Yeah, so the question is, are you still in beta testing? I would be open to testing.
Yeah. Yes, we are, and yes. In fact, if that individual wants to reach out to us on our website via the contact page, that'd be great. If we don't have contact info for them, but um, yes, we're interested in getting more testing accomplished. The more that we can field these systems, the more we're going to learn about the customer needs and ways that we can improve upon our processes.
Yes, yes. So, which industries are you seeing the most potential for such a system right now in?
So we did originally set out to provide a security and safety of life enhancing capability. However, there's really no reason that this system couldn't be used for 2D or 3D surveying,
Mm-hmm.
for agricultural missions, for crop yield analysis. The sky's the limit when it comes to these autonomous drone applications,
Right,
and we just haven't even gotten started as an industry. It,
right.
it is so early. So our philosophy is to be as flexible as possible and try to provide a product that can enhance the overall autonomous drone industry.
Right.
I don't think people realize just how many drones are going to be in the air here in just a few short years. I do believe we're going to see exponential growth in certain parts of the world.
And for this exponential growth, drone autonomy is extremely important, right? You can't expect each of those drones to be piloted by an actual human user.
The drones are simply more capable when
Yes,
they're flying themselves. That's really the bottom line. Um, and as I mentioned earlier, with the network effect, there's so many neat things that can be done with an interconnected network of drone docking stations and drones.
right, right. So one of the questions is, can you place this dome on a back of a truck and kind of serve mobile applications?
Yes, yes. So it does fit in a standard truck bed. Is at its widest point. It is, I believe, 52 inches. So it will actuate. It'll open and close just fine in the back of the
Uh-huh.
truck. It has a GPS receiver on board, so it can report its position if the drone needs to land in a different place if the truck's moved. So yeah, that
Right.
is something that we have been working on and expect to see media reflecting that capability on the website here in the coming weeks.
Right. So one of the interesting points you mentioned during the presentation is that you used materials which are like fiberglass because they allow the electromagnetic radiation to pass through. And the reason for this is so that the drone would always have its GPS location even when the enclosure is closed, right?
Yes.
So which application is this pointed towards?
That's primarily to rapid response to security and safety of life missions. So we developed an integration with the security software Milestone X Protect, whereby we can trigger a launch out of the dome based on some other sensor on the ground triggering that event. So if someone is trespassing on the property, you want a fast response.
Right.
And if the drone needs to be powered up, well, as we all know, that can take upwards of a minute
Right.
for it to go through its checks and get a GPS fix. So we really want the craft to be powered up and have a GPS fix. The fiberglass enclosure is more or less radio frequency transparent. So in addition to the GPS fix, it can communicate with its RC unit in the case of like a legacy DJI product. Um, but the dome also has its own LTE router. So by using RF transparent materials, we don't need to put any antennas on the outside.
So
And
please continue. I'm sorry for interrupting. Go ahead.
and that's helpful, right? Because without having antennas, it's one less thing to worry about getting damaged by weather.
So does this counter dome contain the RC or is it a separate unit?
In the case of a DJI deployment, the RC unit is inside the dome. It can be placed in that storage area if the customer desires, or it can be placed below in the mechanical section.
Right.
We also have the ability to remotely restart the DJI RC unit because we've found that DJI products need to be restarted.
Yes, absolutely.
Once a day, it seems about the minimum. So
Okay.
so we can do that with a battery, a DJI battery that we can provide, and also we can do that with the RC units. So and we're not limited to DJIs when it comes to having an RC unit inside the dome. So we
Okay.
can do that with other manufacturers or with custom craft that use like Dragon Link radios or Crossfire radios. All of that can be integrated.
And this does not affect the range of the flight range of the drone, right? Placing the RC inside the dome.
No, not so long as you have line of sight. Which so it really comes down to the line of sight between the dome and the drone. So
Yeah.
it's just like any other time you're using a handheld RC unit. You still need line of sight.
Right.
If need be, if requested by a customer, we do have the ability to use higher gain or amplified antennas for some
Okay.
applications if the landscape dictates that.
I see.
But ultimately, the solution to all of that is LTE. And if LTE is unavailable, then to use Starlink is really what we're looking at for later this year.
All right. Okay. So just a couple more questions before we finish this, right? So obviously you have outlined a lot of benefits to having a two drone system. Have you found any disadvantages to this system?
I'm sorry, say that last part again.
Have you found any disadvantages or risks to this system of having two drones?
So it is a little more complicated. We did have to devise a method by which we can deconflict the two craft from each other.
Right.
But we're confident that as configured, the two drones can operate without causing one another a problem. So it has been developmentally a little more difficult. When we started this project, it was going to be a single drone system, but we
Right.
found that using a circular floor gave us a lot of options.
Right.
And we found a configuration that comfortably fits two 350 millimeter wheelbase drones. So I don't think it's a disadvantage going forward, but it did take some unique development.
I guess you would have to coordinate the takeoff so that both drones don't take off at the same time, both the drones don't land at the same time. All of this coordination would be handled by your software.
Right. So in the case of the landings, we know that if one drone is in the correct charging position, the other drone will clear it
Right.
upon takeoff and landing. So basically, that's the gate for further actions. Are the drones in the correct charging position? And if not, then they reposition. So that spacing is built into the charging system.
Okay. And the counter drone, I guess the software, it also makes sure that when the drones are flying, they do not get into any sort of collision paths with each other.
Yeah, they're not going to recover at the same time. That would be hazardous, I think, even given how much improvement we've seen in the precision landing capabilities. That's something that we do not recommend attempting. So, deconfliction between the drones at the docking station is built in by virtue of the fact that they're not allowed to land at the same time.
Right. All right. The last question is, if somebody was to give you and place an order with you today, how soon would they be able to get it? And obviously, are you ready to ship it globally?
Yes. So if an order were placed today, we anticipate delivering systems mid to late April, mid-April in the U.S., late April, like in the Asian or Australian markets. But that's our current timeline.
And there is no problems with delivering globally, right? You have your customers all over the globe, and there is
yes, we absolutely intend to ship globally.
Great. So I think, Sean, that brings us to the end of the session. And if anybody has even more questions for Sean, you can just visit his booth at 6:30 p.m. UTC. Sean will be there live, and he will be there to answer your questions. You can have a one-on-one conversation with Sean and clear your doubts and be fully updated about what CounterDome is and what is CounterDrone doing. So lastly, Sean, I would like to thank you for joining us today. Your insights and expertise have really blown a lot of people's minds, I'm sure. And would you like to share any closing thoughts before we end the session?
I really appreciate the opportunity, Havish. And if folks want to visit our website and they can use the contact form there, but we'll also be in the virtual booth here shortly to answer questions. But we look forward to being a part of this emerging industry and are grateful for this opportunity. So thanks, everybody.
Great. So I too would like to conclude by thanking everyone for joining us today. Please visit the reception and the sessions tab to learn more about the upcoming networking roundtables, which are going to start soon, and the booth visits. So yeah, thank you. Have a great day. See ya. Thank you, Sean.
Bye.
Bye.